So my name is Heinrich Schuchardt. I'm working at Canonical as RISC-V lead engineer. And I want to tell you where we are with Ubuntu on RISC-V. So let's just have one slide remembering what RISC-V is all about. RISC-V is a new instruction set architecture, but to be truthful, it's really all about a new business model. It's about having open standards, having no restrictions to extending on the technical side, having no royalties, and this is really what's changing the industry. And what we see with this new business model is that it's a really fast-growing ecosystem. Microcontrollers are already used in the billions. There are affordable developer boards which came to the market last year. Server-grade hardware is expected this year. We see good software coverage, and we expect RISC-V to replace a good bit of ARM usage. For Canonical, RISC-V is really a first-class architecture, and therefore also for the Ubuntu distribution, it's a first-class architecture. And you see this also if you simply look into our archives and see how many packages already exist. So if you would put x86 at 100%, you can say 93% of all packages are available for RISC-V. And here at Embedded World, of course, you're interested, are there all the developing tools that you need? Yes, they are. So you have Python, you have Java, you can use Node.js, Go, C, C++. The one thing that is still coming up is the .NET environment. RISC-V has already been ported to Mono, but the runtime environment is what is currently in the making, and we will also see .NET being supported. In embedded devices, you often use containers, so you can already run Docker or LXD on your RISC-V devices. You can use, of course, QEMU for RISC-V devices. If you're using RISC-V as a desktop, you have GNOME or KDE available there. So if you are developing directly on a RISC-V board, you have the whole desktop environment available. But what's much more important here for the embedded world, of course, is that quite a lot of IoT-relevant packages are already there, like the robot operating system ROS, like OpenCV if you want to analyze images. I would be able to show you a demo out at our booth. And, or for instance, MQTT for collecting data from IoT devices. All these packages are already available in the Ubuntu distribution. We have been striving hard to make it as easy for you to run Ubuntu on RISC-V by supporting a lot of boards that have been coming to the market. So the first boards that we supported was Unmatched and Unleashed from Sci-Fi. So these were really meant for the first developers really to get on that IP. Unfortunately, they are not available anymore. Several Raspberry Pi-sized boards were coming to the market, like the Starfight Vision 5, of which there is a new version this year, or the winner D1, the Zypit Licia V board, and all these we have got supported inside Ubuntu or the distribution. And this year we have been porting Ubuntu onto the PolarFire Icicle kit, which is a board which is meant for FPGA development, but of course you want, besides the FPGA run application, also have the possibility to run a full Linux on it. And as I said, there are more boards to be expected. One board that just is hitting the market is the Vision 5.2 board from Starfight. That is about the most powerful thing that you currently can buy, and it's below 100 euros. When you think about how you want to implement in IoT devices, there are different approaches that you can take. One is using Yocto to build your completely own distribution. But that means all the load is on you. You have to maintain the whole distribution. You are responsible for everything about security. You have to find out how to do upgrades. And an alternative to this is Ubuntu Core. This is, besides the normal distribution that we have for the desktop, is a distribution where everything is containerized, which is a managed distribution where you can manage devices easily, with security built in, with safe transactional updates. Just to give you an image of it, so everything in here is a container. So it starts with a kernel snap, which is really at the base of booting up the board, the core snaps that is managing all the other snaps. And then each application is a separate container, and these separate containers are secured by AppArmor, by container system as the namespaces that are coming with it, and can have separate writable partitions so that you can really keep them very tightly locked. And as I said, one important thing is really transactional updates, so that when you are changing from one version of an application to the next version, that you can do this seamlessly. So a device running Ubuntu Core can just look on the web for the new versions of the snap, and when it upgrades, it really makes a copy of everything. You retain the old version of the snap, the old data, and have a separate area for the updated data and the updated snap. And in case anything should go wrong, you could easily roll back to the old version and would not lose any data. And this all comes backed by a store. There's a global store where every developer can post snaps, but you also can have your company private stores. And on these stores, we already have some of the RISC-V applications as snaps available. Thanks a lot for your attention.